Data comes in many shapes and sizes. If you want to analyze it correctly, you first have to identify which shape it fits into. Today we are comparing the three cornerstones of the statistics: the binomial, Poisson, and the normal distribution. Let's look at these assumptions and when to use them, right? So the first one is the binomial distribution. Focus on the chart, this one, right? So first up, the binomial distribution thinks of this as a coin flip distribution. Its key assumptions are rigid. You must have a fixed number of trials, and every trial can only have two outcomes: success or failure. So here is an interactive face animation which we can see. So let's just say if we have a 20 number of trials and we have a probability of 50%. So as I'm decreasing the probability, the average number of audience or the average number of data is moving towards left, and as we moving it, increasing the probability, it is moving towards right. And number of trials just makes it more accurate, right? Visually more accurate. So this was all about the binomial distribution. Here is the formula which is applied: nx px 1 minus p n minus k. And if we move, next is the Poisson distribution. So think of this as a call center distribution. While binomial counts successes in fixed trial, Poisson counts events occurring over a fixed time or space. The main assumption here is a constant average rate called lambda. So here is the formula which is lambda upon k e minus lambda upon k factorial, and here is an visualization of the Poisson distribution. So lambda means 5 means the number of times that event is happening in a fixed interval. So 5 means that interval is happening 5 number of times. So as I increase the lambda, the visualization really doesn't change that much, right? It just, if the lambda is 20, it will be, the mean will be 20, right? So it's a basic visualization of Poisson is kind of easy and straightforward. The next distribution comes is the big one, the normal distribution, or famously known as bell curve. Unlike the previous two, this handles continuous data, measurement that can have decimals. Its assumptions are symmetry, and the shape is defined entirely by the mean and the standard deviation. So this is the actual assumptions and applications. If we see on the visualization area, if I keep the mean in a negative terms and the standard, if I reduce it a bit, you can see we are getting a bell curve, right? So increasing the standard deviation means you are giving more space to spread out, right? So it will be like more, will have a more width, and if you decrease it, the width will also decrease. And if you increase the mu, if the mu is 1, it will be a right skewed, and if it is less, it will be somewhat left skewed, right? So this was a visualization of normal distribution. So here's your cheat sheet. Are you counting distinct successes in fixed trial? Use binomial. Are you counting events happening over time? Use Poisson. Are you measuring continuous data that clusters around an average? Use normal distribution and choose the right distribution, right? So this was all about in this video. Thank you.